Okay, today we're going to be on 1.4 with matrix applications, and there's just two applications we're looking here for. First one is to find the area of a triangle. This is the formula we're going to be using here, and you're going to be given three vertices. You will notice that the x coordinates will be listed in the first column, the y coordinates will be listed in the second column. And then it's just the determinant of this number. We are going to be able to use a calculator for it. You will notice the plus minus here. That's here to correct if we get a negative determinant. So let's go ahead and set this guy up. Whoops. Alright, so let's go ahead and set this guy up here. What we're looking for is to find the area of this triangle. So it's going to be plus minus 1/2. You're going to list the x coordinates down the side here, then the y coordinates, and then the third column is always ones. You can go ahead, we'll do, I guess we could do this one by hand here. Let's go ahead and repeat here. Remember, we're multiplying down on the diagonals going this way first. So that would get us, let's see here, plus minus 1/2. We have 2 plus 0 plus 6. We're going to subtract out on the diagonals going in the other direction right here. So that would get us 0 plus 3 plus 8. Again, we're at plus minus 1/2. 8 minus 11. Plus minus 1/2. We've got negative 3. Now we're going to choose the negative one, so we have an area of 3/2 units. Again, if it doesn't say to solve by hand, you can use the calculator to get the determinant of the 3 by 3. Alright, let's move on to example 2. Keep doing that. We just need to move down here. For example 2, we want to get the equation of a parabola, and we know that it's passing through these 3 points. At this point, we're going to use the fact that the equation y is equal to ax squared plus bx plus c. So, we're going to put the y, however, on the right. So I want to set it up. Ax squared plus bx plus c is equal to y, and that will help with our matrices. We're going to use this first point. This is going to go in for the x. This is going to go in for the y. So we're going to have a times 1 squared plus b times 1 plus c is equal to 9. Then we'll do the same thing for the second point. We will put that into the x, the 2 into the x, the 8 in for the y. So you're going to have a times 2 squared plus b times 2 plus c is equal to 8. And again, with the third point, we will do the same procedure, putting the 3 in for the x. So a is equal to 3 squared plus b times 3 plus c is equal to 5. This is going to simplify down to the equation of a plus b plus c is equal to 9. We're going to have 4a plus 2b plus c is equal to 8. And then we will have 9a plus 3b plus c is equal to 5. So for work being shown, when we're talking about this, we do need to see this piece over here. Then you need to change it into the matrix equation. So we start with the coefficient matrix. 4, 2, 1, 9, 3, 1. We have the variable matrix of a, b, and c. And then we have the answer matrix of 9, 8, and 5. At this point, we're just going to be using the calculator to solve the equation here. You will find the inverse of the coefficient matrix and multiply it to the answer matrix. You should be getting a is equal to negative 1, b is equal to 2, and c is equal to 8. If you have any questions with a calculator, please ask your teacher. And with that, we conclude our unit on matrices.